Okay, so first thing is I'm doing my declarations. You saw there was 3 big requirements that we had to do in there. One of them was we had to count how many words were entered. The next thing was we had to, when we encountered a period, we had to dump out a sentence. And then finally, the third big feature was quitting on someone just putting an enter in. Okay? So those are the 3 big things we had to do. And so the first thing is I initialize my things here. I'm going to use this variable to accumulate my sentence. Here, this is what I'm going to use for my counter to count how many words come in. This is for my input. And so enter 1 word at a time. I'm going to read the whole line, and I'm just going to treat it as 1 word. They follow the instructions. So here, I accumulate my sentence into my sentence variable, increment my word count. Okay? Now I start to do the other checks. Was this empty? If so, well, it wasn't a word. Let's decrement the word. Let's quit and print out your word count. Otherwise, did that word contain a period? If it contained a period, let's dump the sentence and reset my accumulation. Then loop until we get the quit. This is my solution. Now you could have this word counter in other places and avoid this decrement. That'd be totally fine too. I just made the decision to have word counter once and then unwind if it wasn't a word. Any questions about this? Okay. This is available for you to review, and also my discussion has been recorded. I'll put it up on YouTube and link it to the syllabus sometime today. So now, let's do the review. So I constructed this review based upon all those assessments you guys have been submitting. I went and looked at all those, and the ones where there was the most contrast, that's what I decided to cover today. Whatever time's left after I go through these, then we'll take Q&A. Here's a quick way to try to remember the data storage. If you can remember these 3, you can derive the rest. If you can remember int and float is 32 bits and a car is 16 bits, then you can derive the rest by going lower by half. By having it each time, you can walk down the chain from int to short to byte. By going up the chain, you can just double things from float to double and from int to long. Quick way to remember the mins and the maxes. 2 to the storage minus 1, the negative of it, or 2 to the storage minus 1 minus 1. Quick heuristics to try to remember this stuff. But you only need to know these, and then the algorithm for deriving the rest, and then maybe these. So references was an issue. And let's take a look. This one got probably a lot of issues. Got a lot of wrong answers. And so let's look what's going on here. So we have our stack, and we have our 2 variables, hello world 1 and hello world 2. When we first declare and initialize hello world 1, that's going to point to here. It's going to have something that looks like this, which is going to point to somewhere on the heap with the actual string. Now, when we do assignment with strings, what gets assigned, so hello world 2 gets allocated, space allocated on the stack, and then the value of that variable gets copied into that to that allocation. So what happens is that this one here gets this value copied into it. Okay? Now, this is where the trick happens. When we reassign Hello World 1 to Bonjour Le Monde, what happens is different part of the heap is allocated for the string, and then this guy, the value here, gets changed to point to here. The value stored, the value identified by hello world 2 is still pointing to here. We change the value stored in those variables, not the references they were pointing to. Which is why the second one still says hello world in English. Okay? This is something that you really need to understand about the difference between reference variables and primitives. Okay? Java always stores some core value in the variable, in the memory address identified by the variable. When it's a reference, that value that's stored is an address somewhere else, a pointer. Simple. Now, by the way, this is Java. Other languages may do things differently. Okay? Just so you know, this is Java. So let's look at how we declare strings and what the different components are. So I think maybe the on this one, I think a lot of the confusion might have been on what I was asking about. But if I ask for the identifier, I'm asking for the name of the variable. Right? If I ask for the literal value, I'm asking for the contents, what that variable is, the value of what that variable is. I'm not asking for what's this method, or what the contents of this, the result of this method call would be. I'm asking for hello world, and then what's this symbol? Okay. Identifier is the name of the variable. Literal is what that value is, what that variable is. So, when we did the carrad exercise, there were a lot of y'all did the first thing. I want to give me the first character, right? The way Java does arrays and indexes is being zero based. So the first character is zero, zero index. I don't know of too many languages that aren't that way, where the zero index is the first one. So this should actually be 0, 1, 2, 3. Okay. This will give you an error. So just note, Java indexes are zero based. Length is 1 based. So if we said the length of that, it would be 4. But if we want to iterate through it, we need to iterate from 0 to length minus 1. Javadocs. So if you look at the outcomes, one of the outcomes is that you need to be able to read the Javadocs. One of the outcomes specifically says you need to see if something's in the Javadocs or not. So this one, replace last did not exist in the Javadocs. And that was the point of the exercise, was did you go look for it in the method section? Could you identify what the method section was? Was replace last there? It's not. So the answer should have been replace last does not exist as a method on a string. And you need to be able to traverse those docs. Okay, you need to be able to look at them. Look at them for reference. I've been doing it in class. Maybe I haven't been doing it enough. So this one, I've already talked to a lot of y'all individually. This one got a lot of problems with. Interestingly enough, you guys got the outcome right, but the reasoning wrong. So, actually, it's on the next one. So let's look at what's happening here. So if we have the post increment operator, what this says is use the value first, then increment j. Use the value first in this expression or statement, then increment. which is why this 10 gets puts in here, and then after that 10 gets put into here, j becomes 11. On this one, it says increment first, then use the value j. So 10 got put in there, now j is 11. Here we're going to increment j, j is going to become 12. We're going to print out j, which is 12, and we're going to print out 12 again. Use first, then increment, increment first, then use. Here's what I was referencing earlier. A lot of y'all got 22 correct. But not many of y'all got the reason why correct. So this is what's going on. J gets to increment first. That means this becomes 11 and that becomes 11. Increment j first, then use it. So we use it, so j gets swapped out with 11. This says use j first, which is 11. So this gets swapped out with 11. Then it says increment j after we used it. Okay? So this equation is j is equal to 11 plus 11. Now, because we have this double assignment of here and here, this is the one that gets used, and this gets dropped. Let me repeat. This does nothing to the equation. Okay? And that was further demonstrated. A lot of people got this 22 right, but then they missed down here because we didn't understand what's happening. So in the next problem, A got incremented to 6 because it's increment the value first, then use it in the expression. So this is 6. Then it says use B, then decrement B. So B gets plugged into here as 10, then B gets decremented to 9. So this would be 6 times 10. Then if you print out C, it's 60, but if you print out B, it's 9. So I think the best way to remember this is read it left to right. Operate first, then substitute, then operate. Conversions. So in this question, I asked what the safest fix would be. And safety, when we're talking about converting data types, means not to lose information. So if we change this to a cast, this would actually become 18, and we would lose this information. So the safest fix to this would actually be to change this to a double. That would be the safest fix. Safety in conversions means not losing information. The reason why that's important is because when you're not losing information, Java will do a lot of conversions for you, and you don't have to explicitly do them in your code. This is the next one. So a lot of people got this wrong because this is what happens. These are two ints. Whole numbers by default are ints. So this integer math happens. This becomes 0. Then it gets converted to a double. Because we can safely go from an int to a double, right? It's 0. We can safely go wide. So then this gets converted from 0 to 0.0. The integer math happens first. We can safely widen to a double. So 0 becomes 0.0. Now this might have been a little tricky because I didn't explicitly cover this, but this is just the syntax. We can do capital L to denote a long data type. Otherwise, I'll think it's an int. So the D says this is a double. We can do capital L, F for D. F to indicate float, D to indicate double, capital L to indicate long. Then there's some other things just if you're curious. Safety is the big thing. We can go wider. Narrower causes problems. And then you always have to be aware of integers, especially integer division. For a constant, two things are important for a constant. One of them is the grammar. And that is, we must have this final keyword, or it's not a constant. Final says, compiler, this is the final time I'm going to assign anything to this variable. So then what the compiler will do is everywhere it sees this, it will do a literal string replacement in the source code. So there's no memory allocation at all for a string variable. If you don't have the final keyword, then it will allocate memory for this string. And it'll be a variable with a reference. Then it's not a constant. The second key part is our naming convention for constants. This is professional practice so that everybody else who does Java knows that this is a constant. Use all caps, separate words with the underscore. If you use constants on an exam, those are the two things I'm going to look for. Both of them. Repeating. I took someone's solution for this. This is the one where it says, give me a phrase and then a number of times repeat, then I'll repeat it. So this is my commentary on this particular solution. So this here, we don't need this quit equal to false. We can just say quit, because quit's a boolean. So we don't need this at all. This is redundant. Okay? First. The second one is, since we only need one scanner, and this loop's happening, this is actually a pretty expensive operation. Every time you loop, you're going to make a new scanner and grab a new reference to the standard in. And that's fairly expensive. So what I'll do is I'll move this out of the loop. So we only have to declare it once. Now, if you did this on the exam, I wouldn't take off. I would just comment for you. Okay? But anytime we do object allocation, it's expensive. You see people, you'll really get to know that. You know what I mean by expensive? I mean computationally. And now let's look at this next one. So this was perfectly fine. It equals ignore case, and even though this is syntactically correct, we do a single line if, put it on the same line, I would dock you for not putting it on the next line and not putting it in braces. Because this is hard to read. It's hard to read if this gets more complicated. Comprehension is 50% of what we do as programmers. Clean code, and it's code that we can understand, is incredibly important to our craft. Okay? So don't do this. Put it on the next line, use braces. Don't do this. Otherwise, this program works. I think most of you are fairly close on that one. Okay. So any questions? We've got about 10 minutes. Any questions? Katie? No questions? Okay. I mean, y'all free to go. 10 minutes if anybody wants any one-on-one time. We got 10 minutes.